Did this flat earther just mathematically prove that you cannot see curvature from an airplane?
So, you want to know why there are no photos of the flat earth? All right, let's do that.
To be honest, I didn't even know that this flat earther was still making videos after last year he claimed that there are some places that the sun sets to the east. All right, let's do that.
It's mathematically impossible to see the curve of the earth from an airplane. Felix Baumgartner did not get high enough to see the curve. Why do you think they propagate something that is a mathematical impossibility?
So his claim is pretty simple. You can't see curvature from an airplane. Even Felix Baumgartner at like 29 miles up wasn't even high enough to see the airplane, according to his math. Let's take a look.
Why is it that you think that when you ask Google how high you have to be to see the curve of the earth, it'll tell you 50,000 feet? But when I ask ChatGPT to use only math to calculate how high you would have to be to see the curve and not just a Google answer, it tells me 147.08 kilometers.
And as we all know, ChatGPT is 100% of the time. And don't bother wiping this off your screen. It's on his screen. And I'd like to point out down here at the bottom, it says ChatGPT can make mistakes. Consider checking important information. Derek, it looks like you didn't check the important information. Well, let's look and see what we got here. So we got a formula to calculate the distance to the horizon, which is d, based on the observer's height, which is h. And this is that equation. And you can see it is d equals the square root of 2 times r, which is the radius value of the Earth, times h plus h squared. And remember, what we're looking for here is how high we have to be in order to see curvature. So we are trying to find this h value. But when we come down here, ChatGPT for some reason plugged 1.7 meters into the h value, which means this is actually solving the distance to the horizon when you're about 6 feet off the ground. This is not calculating how high you have to be to see curve. That's just not what's happening here. However, this is the correct equation. ChatGPT just plugged in h and solved for d, when they should have been solving for h and plugged in d. Bear with me, we're gonna get into the math a little bit. It's just to help you understand where he went wrong and what the actual answer might be. So here I've got written out distance to the horizon, h equals observer height, and then r is the radius of the Earth. And then this is the equation that ChatGPT gave him. Now what we need is how high you need to be in order to see the curvature of the Earth. So we need to be solving for h, not d. Here are the numbers that I used. 400.3 is 1/100th of the circumference of the Earth. It's about how much of the Earth you would need to see in order to actually see a curve. Any less than that, it'll kind of look straight. And then I used 6,371 kilometers for the radius value, which is the same number that Derek used, or ChatGPT used, in the video. And here it is plugged nicely into the equation. We have these numbers and we're trying to solve for h. So let's do some magic. I've rewritten the equation up at the top. The first thing that we need to do is square both sides to get rid of this square root. So we're going to take the square of 400.3 and then the square of that, which just gets rid of the square root. 400.3 is this squared. And then I also did 2 times 6,000, which is that. And now that we've got these into semi-regular form, we can minus this number over to the other side, setting the whole thing to 0, which is going to give you h squared plus 12,742h minus 160,240.09 equals 0. Now, those of you playing along might recognize this form. Yes, it's a quadratic equation, which means we get to use the quadratic formula. For those of you that do not know, the quadratic formula is h equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is just a rule in mathematics when dealing with quadratics like this. Yes, I've seen the proof, it's big. And over at this side, I have told you what each of the numbers are. A is the number in front of this h squared, which is a 1. B is the number in front of this h, and then c is this number here, and we can plug that into the equation and get this, which is pretty simple to plug into a calculator, so I'm not going to go through the actual math. You get two numbers, which is this 10.825 kilometers and negative 12,752.825. And of course, we know that you can't have a negative number when dealing with elevation, so we can just toss that number out, giving us the 10.825 kilometers. And if you didn't know, this plus or minus is because of the square root and is why we got two numbers. And this is our answer. This is the height that you have to be in order to see curvature. For all of you Americans, that is 6.72 miles. And the average height of an airplane at flight is 5.9 to 7.2 miles, which means the average airplane flight is high enough to see curvature, as long as you have a big enough field of view in order to get that 1/100th of the circumference of the Earth in your view. You can absolutely see curvature from an airplane. You know, using actual mathematics, not whatever ChatGPT spit out for you. And for the record, I went and asked ChatGPT if what Derek got was wrong, and ChatGPT said, if someone asked ChatGPT to determine the height at which the curvature of the Earth becomes noticeable, and ChatGPT responded with the equation of that, then ChatGPT provided the incorrect equation for that specific question. Imagine that. I'd usually end this with gotta light a flurf, but looks like ChatGPT gotta light a flurf.